Hello all, welcome to the channel Electro Ready. In this video, I am going to discuss about FDMA, Frequency Division Multiple Access. It is also known as FDM, Frequency Division Multiplexing. In the early days of telephony, around 1900s, a separate pair of wires needed for each trunk circuit. A trunk circuit is a circuit that connects the telephony switchboards. It is a local loop circuit that extends from a telephony switching centers to the individual telephones. In that time, the demand for telephone services increases. Therefore, the overhead wires also get increases. In the below figure, you can see that how the cities were looked with overhead wires. It is so bursty. So, how this problem will be solved by FDM, Frequency Division Multiplexing. FDM made it possible to transmit several telephone signals simultaneously on a single wire. So several telephone signals means signals of multiple frequencies that are combined for concurrent transmission. So here in this below diagram, the multiplexer will convert the modulated signals coming from the input devices into a combined signal. This combined signal enters the communication channel. In the receiver side, demultiplexer will be used to convert the combined signal into original individual signals. Now we see how the total bandwidth of communication channel is divided. It is divided into frequency band 1, frequency band 2, frequency band 3 and frequency band 4. Each frequency band has some range of frequencies. For example, frequency band 1 is from F0 to F1. Frequency band 2 is from F2 to F3. Like that it goes on. In between the frequency band, it is called guard band. Guard band is used to prevent the interference between the frequency band, and also it prevents overlapping. This diagram also illustrates the communication resource. Communication resource in which the x-axis denotes the time and y-axis denotes the frequency. You may come up with one question that how the baseband signal will occupy the higher frequency band. By using mixer, we can modulate the signals. Here, x of t is a baseband signal of frequency 300 to 3000 Hz. And then the carrier signal cos 2 pi f0 t. It is of frequency 10 kHz. Both this input will be given to the mixer. The mixer will mix or multiply these signals and result the output. This is the output of frequency upshifter version of baseband signal. So in this, the oscillator frequency f0 10 kHz is a center frequency, and then the 300 to 3000 Hz of input will be subtracted from 10 kHz. So 10 kHz minus 300 Hz is 9.7 kHz. 10 kHz minus 3000 Hz is 7 kHz. Like that, 10 kHz plus 300 Hz, 10.3 kHz, 10 kHz plus 3000 Hz, 13 kHz. Like that, LSB lower sideband and USB upper sidebands are resulted. Lower sideband and upper sideband contains same information, but lower sideband will be called as inverted sideband because it is in the order reverse of the baseband components. But USB contains the order which is the same as the baseband components. That is called erect sideband. This is the simple example of FDM. A same input signal x of t is given to 3 different mixers so that it produces 3 frequency shifter signals. First mixer, which is of oscillator frequency 20 kHz. Mixer 2 has oscillator frequency 16 kHz. Mixer 3 has 12 kHz. So that it produces different frequency range. Like this, the baseband signal of frequency 300 to 3400 Hz will convert to a 16.6 to 19.7 kHz, which is of higher frequency range. And then this range of frequencies are summed up and produce a output of total bandwidth 8.6 to 19.7 kHz.